Hey, this is a video for 1.3, Valence Electrons. So go ahead and set up a new entry in your Cornell notes. Remember to start a new page for this video. Also check out our essential vocabulary. Today we'll be discussing valence electron, octet, and electron dot diagram. So just to give you a little review, this is what the orbitals would look like in a magnesium atom. The electron configuration, recall, is right down here. And the valence electron is actually just the outermost electrons according to the electron configuration. So there are two valence electrons in magnesium. We pay attention to this number. This is also 2, but ignore that for right now because we haven't learned it. So in a group, and groups go up and down, they're vertical. In the same group, you're going to have the same valence electrons for some of the groups, not all of them, but for 1, 2, 13, 14, 15, 16, 17, and 18, they'll have the same valence electrons. And an octet, if you look at this prefix, OCT, that means 8. So octet simply means that it is a completely filled valence orbital like a noble gas. So the octet has 8 valence electrons. And these noble gases are also called the inert gases. They're group 18. They're also very non-reactive. So if we look back, these are the atoms that have a full valence. They all have an octet with the exception of helium. Helium only has 2 possible electrons. So the inner orbital, quantum level number 1, is actually filled. It's not called an octet, it's called a duet. But for all intents and purposes, it is also just as happy as the other electrons. So we want to get to this magic number of 8. And within the same period, now period is the groups going across, or the lines going across. This is period 1. They have the same quantum level. In other words, 1 orbital. This is 2 quantum levels, 2 orbitals. This one has 3 orbitals, 4, 5, 6, and 7. So the same period is going to have the same quantum level. And as you increase the quantum level, you are also increasing the energy. Now we're going to show you an electron dot diagram, and this is basically it's a visual representation of the valence electrons. It's not always easy to draw out the electron configuration because some of them get really complicated. It's also not practical to draw out all of the different orbitals. So what we do is we use dots, and we choose chlorine, and chlorine has 7 valence electrons. So what you do is you're going to draw 7 dots around. But you don't just draw them in any particular fashion or any random fashion. You want to go in order. So we start here. There's 1. You go 2. You always want to go clockwise. I tell my students all the time, go clockwise. So we go 1, 2, 3, 4, 5, 6, 7. Now if you notice, they all have pairs except for this last one. If you draw it like this, it will make it easier and much more easy to do future activities when it comes to elements and reactions. Now here are some other examples of electron dot diagrams. Potassium has only 1 valence electron, magnesium has 2, oxygen has 6, carbon has 4, and neon has this wonderful octet where you have 8. So really what you want to do is draw them in a box. Like if you imagine there is a box. You don't want to have them coming out like a cross. I don't think you would lose points on a regent, but it's just, this is the way that chemists do it, and I think this is the way that chemistry students should do it as well. So I would like you to respond to this check for understanding. I hope that this video was informative. I thank you for your attention, and I will see you soon.